Hello, welcome to FX PhD. My name is Matt Leonard and this is class number 7 of arn201 Real World Lighting and Rendering. So in this class we're going to be focusing our time on render passes and AOVs. And AOVs I'm defining as arbitrary output variables, which I believe is the same way that Solid Angle would define them, but I've always considered it to be a kind of a RenderMan term, or that's where I first heard about it. Anyway, we're going to be looking at things like standard render passes, so our diffuse, our specular reflections, things like that. We're going to be looking at those arbitrary output render passes, things like our Z depth, our point, our normals, those kind of things. We're going to be looking at how you create multi-channel EXRs and how you can add metadata into our EXRs. We're going to be looking at custom AOVs using a node we haven't looked at yet, an AI Right Color node, along with creating custom AOVs for mattes. And then finally, we will look at how you can output deep data from Arnold. So first off, let's have a look at what render passes are available to us and how they kind of work inside of Arnold. So you can see from this list that we have quite a lot of passes straight off the bat. The top section, you can see that we have things like direct diffuse, direct specular, emission, things like that. And we have the check mark next to it of the AI standard. So basically what that means is if you use an AI standard, all of these passes down to SSS are available, and they're kind of the passes broken out of that shader. Now you'll also see next to it we have our AI hair, and we also have our AI skin, and they actually share some of the AOVs or some of the passes that the AI standard also uses. So if you were to do a hair multipass, you'd get the direct diffuse, the direct specular, and also the indirect diffuse, and they would be the passes that you would get just for doing a hair multipass. If you were doing something like an AI skin, you would get SSS, which we would also have as a pass from the AI standard, but you'd also get sheen and specular, and they're only available if you're doing a pass based on your AI skin shader. Then we have a group of passes that are called built-in, and these include things like the ID pass, normal, point, Z, things like that, and these are really available across multiple types of shaders, and they're there to give you things like your normal output, your position, things like that. And in amongst those we've got things like ray count that give us the number of rays cast for a current subpixel. You've got things like CPU time, which gives you the CPU time measured in ticks for the current subpixel, and various other things that can be useful to you if you're trying to debug or just look at things in a slightly more technical way. So from here, let's dive straight into Arnold and have a look at the scene we're going to be using and how we can get the first layer of passes out, the more basic ones that you're going to use day to day. Okay, so here we are inside of Maya 2014. The only thing I've changed since the last class was I've updated myself to Service Pack 4. Let's go ahead and load the scene and let me just talk you through it. So we've got a series of spheres that basically animate up and down. It's not the most exciting shot, but it does enable us to cover, you could see what it looks like, and from now on we're going to keep the render settings slightly lower just so that I don't have to wait for too long while rendering out all these passes. Okay, so let's start by having a look at just how the render passes work. So I'm going to come up to the render settings, and I'm just going to set this basically as you would expect. So I'm going to call this render passes, and I'm going to do an underscore. I'm going to have it as an open EXR as we would expect. I'm going to leave everything else as is, though I may choose to put auto crop on because obviously that could be useful. We're just going to go with a single frame, but I'm just going to specify that frame as somewhere in the middle, maybe frame 42. With lots of things going on at that point, and I'm rendering it quite small, 600 by 338. Okay, render settings are as such 3, 2, 2, 2, and 2. And if we come across to the AOVs, this is the important area that we want to focus our time on. So if we click on each of these individual ones, you'll see the available AOVs that you can use. So the built-in, we have our IDs, normals, point, we have Z depth, we have beauty, motion vectors, opacity, ray count, and pref. And then depending on what shader we're using, so let's just call that up so you can be familiar with it. So let's just go with our hyper shader here. Almost said hypergraph, but it's obviously the hyper shader. And just budge this over. Focus in not on mental array, not on Maxwell, but on Arnold. So if we are using AI standard, which we've just generated a 1 here, you can see that the AI standard gives us the ability to do the direct, diffuse and specular, the indirect, diffuse and specular, emission, which is kind of the incandescence, the reflection, refraction and subsurface scattering. If we were choosing a AI skin, we would then have the ability to get out the sheen, the specular, and also the SSS. And if you remember, the SSS is shared with the AI standard as well. There it is down there. If we were using the AI skin shader, the SSS skin, that would mean that we would have even more things. And this is the one that last week I said I believe is being phased out. But you can see there are many passes in here. We have deep scatter, direct diffuse, indirect diffuse, mid scatter, primary scatter, secondary scatter, shallow scatter, lots of stuff going on in there. And then if we were using the AI hair, which we'll be getting to in class number 9, for this we also have the ability to do direct, specular and diffuse, and then indirect diffuse. Okay, so depending on what you need, you can choose from here. You obviously don't need to double up on the passes, so if you were, for instance, to choose the SSS from the AI standard, it would also be available to you if your scene contained skin, for instance. Okay, so they're the same thing. If I choose it here, it moves across to the active AOVs, and you'll note here in the AI standard it's now gone. So it purely shares them, and it just shows you that there's obviously some crossover taking place. So let's go ahead and come to our AI standard, and we're going to grab a whole bunch of these AOVs. So let's shut this down. I can either grab one at a time, and I can move them with this arrow, so they move from this list to this one, and this is obviously very similar to the way that the render passes in mental array work, where they start at the top and then they move down. Here we're starting from the middle and we're moving them across to the right hand side. We can also double click on them, as you saw before, and they then jump across. So I'm just going to take each one and I'm going to add it to our list. Now we also have in our scene an AI skin, so I'm also going to take the sheen and the specular. Okay, and you can see they are now associated with the active AOVs for that particular shader type. Okay, the AI standard, they're now associated with the active AOVs here. Now, in doing this, what you'll notice is that we now have a large list of AOVs lower down, and these AOVs then have a number of things that we can do to describe the information that's taking place with them. So first off, you can define the data type. So if I was to choose the top one, you'll note that we have the ability to say an integer, a boolean, a float, RGB, RGB in alpha, vector, point, etc. Okay, so depending on what you need with regards to the makeup of the pass, you can choose it here. Then we have the driver, and we'll talk more about the driver in a minute, but we have a number of different types of drivers we can use. Firstly, we have our deep EXR, so that's our deep compositing, deep image data EXR file. We have a standard EXR, JPEG, Maya, PNG and TIFF. So what it's going to do at the moment is it's going to save out each of these passes into a separate EXR. Okay, so we're going to end up with a separate EXR. And then finally, we have our filtering. And the filtering here is basically just the way that the pixels are filtered, and you can see there's an absolutely huge list of filters that you can use. For all of the main kind of color ones, we're using a Gaussian filter, but if you feel like you wanted to use something else like a box or what have you, you could come in and make that adjustment here. But I'm just going to leave them all at Gaussian for the time being. Okay, so without any other changes, let's just go ahead and render this and see what we get. So I'm just going to come across to our render menu, and I'm just going to hit batch render. Okay, so now that's finished, you can see in our images folder of our project, we have all these directories that contain the render passes. So we have a beauty pass, direct diffuse, direct specular, emission, indirect diffuse, indirect specular, reflection, refraction, sheen, specular, and SSS. So let's grab all these and take these into Nuke. So I'm just going to load up Nuke. I'm going to take these files and I'm going to drag them into Nuke here. And I'm just going to hit L just to organize them all. And you can see at the moment each one has the same file name. Okay, that'll be something we'll need to fix later on. What you can also see is if we choose one of them, such as this one, and we look at it, you can see that the crop has worked really nicely. So the bounding box is just around the area where the image is. Now obviously on something like this, the bounding box is around the entire thing, but where we have just a single element, you can see that we get a much smaller bounding box. Okay, so some of these obviously don't have anything in it, just because we didn't use that attribute, but most of them have something. Okay, now the way that we put all these together is simply using the plus node. So I wouldn't normally do this, but we can select all of them and just type plus and just go ahead and load them all into a single merge node like so. And then if we view that, what we should get is exactly the same as the beauty. Okay, so now the beauty itself is doubled up. So if we take that one off and then we just compare all the layers and the beauty together, so 1 and 2, you can see very clearly that we're getting exactly the same image. Okay, now we've obviously got the ability to come in and make any changes that we might want. So for instance, if we came across and found something like this one, which is obviously the refraction pass, we could come in and we could grade it. So G for grade, and then we could make any changes that we wanted to, obviously as long as we're actually looking at it. So I believe that's probably the right one. There we go. So we can now directly adjust that particular attribute of the render. Obviously in this instance it's the refraction. We could also come across to something like this one, and this would be the subsurface scattering, I would have thought. Yeah, so that's the subsurface scattering, and you can see here that that's actually the specular area of our subsurface. We could make any changes there. We could equally come back and make an overall change to something like the direct diffuse, which is this layer. So we could come in and make a change there. So I could add a grade node, and then I could just gain up that by a certain amount, warm the whole thing up, cool it down. And again, if we're viewing that, you can see the change that that obviously makes across the image. Okay, standard stuff. Obviously multipass is very well known now, and how you can adjust that in the comp, so we're not going to spend any time on this at all. Okay, so from here let's go back to Maya and have a look at how we can stop our renders appearing in all these folders. Okay, so I'm just going to make a new folder here, and I'm going to say multipass multi-folder, so we remember what that is. Let's grab all of this. I think we've got everything there, and we'll just copy that in, so you know what that is when you come to have a look in the folder. So let's return to Maya and have a look at this concept of drivers. This is very interesting. If I click here on this arrow at the end of any of these, we get this list. We can select the AOV node. So let's say we select the direct diffuse. That opens up over here, and we can see that it's enabled, and that just affects this checkbox as to whether it's going to be rendered out or not. It has the name here that we could adjust if we wanted to, the data type, which obviously relates to the data type that we have over here. We have the default shader that we could adjust if we wanted to, the AOV outputs, and we could make a new option if we wanted to. And then we have this output section here where we can see the driver is the default Arnold driver, and the filter is the default Arnold filter. And that's obviously the driver being the EXR and the filter being the Gaussian. Okay. Now if we wanted to, we could make yet another output of this. So I could make a new output, and here you can then choose a new driver, and you could choose a new filter, but we're just going to leave those as is for the time being, and just go ahead and delete that. and then click back on this arrow here. Next option down enables you to remove the AOV altogether. So I could just choose to remove it, and you see it's gone back in the middle list. Let's just drop it in again so it appears at the top. We could also add a new output driver. So if we chose to do that, we now have a new output driver for this specific AOV. And we could then come in and say it's going to have a different driver. So we could say, for instance, the diffuse is going to have a EXR. And we could then change the filter as well. Okay, now for this, I'm going to go ahead and just remove that output. So output driver 2, remove. However, if we came to into the built-in here and chose the beauty, this could be where it becomes useful. You could take the beauty here. You could say the driver of the beauty is actually going to be a deep EXR output. Okay, so you can choose to do that, and then you have a whole bunch of additional things that you may choose to do with that. Okay, so we're just going to leave all that as is. But this is now going to give us a beauty, which will be a deep EXR file. So we need to remember that that's there, and I'm just going to call it beauty deep. So next time we're in Nuke, we can have a look at that. Okay, now we still haven't got onto the driver. So let's come down and look at the select driver option. Now in the driver, you can see here we have EXR at the top. And if I open it, this is where you could change it to deep EXR, JPEG, Maya, PNG or TIFF. Now at the top of the render settings there is a default driver option. Now if I open this, you can see that here we have a default Arnold display driver. Now if I change this, so say I change it to deep and then I hit render, you'll see that actually nothing now happens. However, if I change it back to Maya, you'll see now the scene renders as you would expect. Okay, so I'll just minimize that. I'll just leave it for one moment just so you can see it beginning to render. But this is very important. The default drivers, default Arnold display driver, is the display driver that we're actually going to see in Maya when we hit render. Okay, and that's what we want. We want Maya to be the default driver so we actually see it. Okay, that's probably taking a little bit of time to get started simply because of the screen grab, but I can guarantee that it's going to appear rendered there. Okay, so let's come back to our driver here. I know it's open, but I'm just going to select it again just so you know it's the right one. Next up, you can see if we were to change this, we then get some different options. So we could say we want to output the driver to an image format of JPEG, or we could go with Maya, or we could go with PNG, or we could go with TIFF. Now some of this isn't as relevant as you might think because we know that we can come to common and we could output it here as well. But as we change it here, it actually changes it in the common as well. So it's actually very clever in the way it connects them together. So I'm going to come back to EXR, and here you'll now note that you have EXR available to you here. If I change it to deep, we're now going to have this set to deep here as well. Okay, so I'm just going to switch it back to EXR. Return to our AOVs. Here we have now the ability to say what kind of compression we want, whether we want to keep using auto crop, whether we want it tiled, etc., etc. Now also in here we have this metadata name, type and value, and this can be really useful. So here I can add a new attribute. So if I add a new attribute here, and I can say what do I want this to be. So I'm going to have a look first at the data type. So I'm going to say that I just want a string, some information, and I'm going to say that this is Arnold, and it's going to be the scene info. Okay, so this is going to be the name of the metadata, and now I can define what the metadata is actually going to say. So I'm going to say that this is class 07 main scene. Okay, so that's my bit of metadata. Obviously we could have an integer, a float, matrix, whatever we want to put in there, but I'm just going to go with this piece of information for an example. Now below that we have this really interesting section which is merge AOVs, and in selecting this, anything that is using the EXR driver will then output this. Okay, so it's not going to apply to our deep information, it's only going to apply to the driver that's the EXR, which as you can see is everything other than the beauty deep section here that we've just added. So this will now put all of the passes into a single EXR file. Okay, so having made these changes, added the metadata, added the deep information and clicked merge the AOVs together, we can then see that the output is going to be both the GUI and for batch. So we can now happily come across to the render and again batch render. But I'm going to make sure that I just change it here just to make absolutely sure that we're getting the right thing. So this is going to be batch render 01. Okay. Now, during my last render, Maya crashed, which is why this is all kind of reset itself. So I'm just going to very quickly go back and fill in these numbers again. 42, I believe it was, and 42. And everything else looks good. So we're just going to go with a save. Okay, so it crashes again. These things happen, as you know. And save as, and then just again do a batch render. Now if I open up my Finder, what you're going to see is here in this image folder, once it starts going, we're going to have a single file, not multiple directories appearing, but a single file appearing, which it will then gradually obviously fill up with data as the render goes through. Okay, so I'm just going to leave it rendering for a moment. There's the file coming in. Firstly, the deep information. So that's the deep file there. And then you'll see in a moment we'll have another file which will just be on its own, just like this final render here was on its own. Okay, so we're just going to leave this rendering and I'll come back in a moment. Now, if you try and load in the deep information, you're going to find we have a problem. So if we make a deep read, and we navigate across to our beauty deep here, and we try and load it, you're going to find that it's completely blank, okay, completely empty. There is deep here, but we're not seeing anything, okay? So from my experience, what I've ended up doing, if we just go back to Arnold, load up the render settings, let's just go with a batch render 02 for this one. AOVs, just for this one, I'm going to come into the deep driver, select driver, and I'm going to set it to merge AOVs. So right down the bottom, merge AOVs here. Okay, so that's all I'm going to do. That's the only change. I've kept it on the deep EXR, but I've now chosen to merge these AOVs. That's what you seem to need to do. It's going to render it out as 02. So close it down and re-render again. And let's see what that looks like in Nuke once the render goes through. Okay, so that's finished rendering. Let's jump back into Nuke. Let's make a new deep read. You can see here now we have our batch render 02. So I'm just going to go ahead and load that. And I'm going to just start by doing deep samples, deep to samples, or deep samples rather. And if we view that, you can see immediately we now have some deep samples here. And if we come to our RGB, there is our RGB information. So if I come over here, you can see that we have those 3 or 4 deep samples. If we jump back to Maya and we select our perspective view, let's just output that. So I'm just going to output my selected camera to an Alembic file. Just going to call it camera. Export selection. Back to Nuke. Just going to read in that camera. Camera. Read from file. Go to file. Up to cache, Alembic and camera. If I view that, you can see there's my camera in the right place. If I now make a deep to points, add my camera and my deep data, look through my camera, and there is my deep information available to me straight away. Okay. Again, if I just move out from my camera, you can see there it is. Okay, so it's very straightforward to get deep data now straight out of Arnold. Okay. Now if we go back to Maya again and we just select our information, you can see under here what we have are all these tolerances. Now what these tolerance values are is they basically define when something is merged. So if 2 samples have a layer value difference bigger than the threshold, they won't be merged. Okay, and so I can specify the threshold here to determine how much they're going to be merged. So alpha, depth and beauty. So I tend to leave them as this. It works quite nicely. If you make the tolerance less, you're going to end up with many more samples. Okay, so if I take my alpha down to 0.1 and my depth down to 0.1, okay, and again just going to call this batch 3. I'm going to re-render this, batch render. While we're waiting, let's just go back to Nuke. I'm going to keep my samples here, so if we load up this, you can see my sample is right here. All I'm going to do is switch the deep read once it finishes rendering, and you'll see that we've gone from 4 samples to many more because of that tolerance change. Okay, so I'm just going to finish letting Maya render, and then we'll do that test so you can see what the tolerance is actually doing. Okay, so that's just finished rendering. Jump across to Nuke, make another deep read. We'll just load in that new file here. Open. Let's just view that. So it's the same image. Add our deep samples, and you can see now we have a few more samples available to us. Okay, so the tolerance makes some difference, but obviously depends on how much overlap and information of depth there is in the scene. But even for our scene, we do get some changes, just a small change for making that tolerance adjustment inside of Arnold. So from here, let's go back into Maya and have a look at some of the other outputs available, such as point position, normals, Z depth, etc. Okay, so let's jump back to AOVs. Let's scoot on up and let's get rid of some of these now. So I'm just going to delete the deep one, and I'm going to take all of these ones and I'm just going to move them straight over back to the middle, and the skin as well, so we don't end up with too many different files. This one I'm going to call batch04 underscore AOV. Put this back to EXR for the main driver, and we're now going to come to built-in, and let's just grab a number of these that may be useful. So let's grab normal, point, Z depth. We could have beauty we've looked at. We've got obviously our motion vector, our opacity. So let's go with these 3, and we'll throw in motion vector as well. Now you'll notice here that the filter is slightly different. So the normal is Gaussian, the point is Gaussian, Z depth is closest, and the motion vector is Gaussian. So let's again just do a batch render of this. Okay, so that's finished rendering, and read in that file. So let's just go with read, and we want the AOVs here. So let's just have a look at a couple of these. Obviously it's pretty straightforward how many of these work. Let's go with our Z depth first of all. So if we have a look at our Z depth here, shut that off. Data's here, it just needs grading, so let's just go ahead and do that first. So we'll add a grade node, G for grade, if you use the hotkey. Now we can see here we've got values around 11, something like that. So I'm going to start by setting my black point to about 11, and I'm going to turn off black clamp and white clamp and say that the channels I'm going to be grading is my depth, and we immediately get to see something. So zebra stripes on, and now we affect the black point until the zebra stripes disappear. So we just bring this back, so somewhere around 12.4 is a good value. If I now do the same to my white point, just continue to increase that, and you can see there that it's just coming in. So white point at 5.2, clamp the black and the white now, and maybe just feel the need to grade it slightly, whatever you fancy doing. Having done that, let's go back to our RGB. We'll turn off our zebra stripes. We'll now use a Z defocus, which was just off the bottom. Sorry about that. So we're going to come in here. Let's choose, say, this one here at the front. So first of all, we've got our depth channel. Now, the one that we're rendering through for our depth pass is obviously depth.z. So we're going to stick with that. We're going to say our output is our focal plane setup, and I can now increase my depth of field to give me a bit of green there. So I'm going to say just the front ball and a little bit of the ground is going to be in my focal point. I can turn off show image if you find it easier. I'm going to set the shape not to a circle, but I'm going to set it to a blade here. Change my input back to, or output rather, back to result. And there you can see we've got some depth of field taking place. Okay, if we want more, we can just come in and adjust the size. Give it a moment to render through, and there you have it. Okay, so really nice depth of field, just working straight out of the box with the Z depth. Now we've also got our point and position. I'm sure you're very familiar with these. So with our position or points, we can use a position to points, points being point cloud. So we can drop that one on, and if we view that, setting the normals here and the position P and N, and zoom on in, there you go, there's our position pass. And then if we wanted to use our normals, we could do a relight. And the way this would work is we've got a input for color. I'm going to bring that up to here. I'll just drop this somewhere here. We've got a input for lights, and I tend to use a scene node. And I would just connect this up like so. And I'd add a light. And I'd drop my light into my scene node. And then I would just move it until I was happy with it. So let's move it up, forward, and over to the side a bit. Okay, now under here that you can't quite see because it's hidden, we've got an input for our camera. So I need to make a camera again, and we know that our camera information is available to us in our Alembic section. So let's just jump across to there, cache Alembic camera. So that's going to go in here, and the last one, that is material. So I'm going to add a Fong shader. So that's going to go in there, Fong. Okay, always difficult to get this to look neat. And if you know me with Nuke, I like it to be neat. If we now view that and go back to our 2D, we need to make sure, again, as we did with our point, that our normals are set, N for normals, P for points. And then as we adjust our light, you can see that then automatically relighting that. Now the way I tend to work with this may not be the correct way. I've never found anyone that's actually definitely said it has to be this way, but I tend to do a merge, and I set my merge to be a geometric, and I say this is the A and this is the B side. Just budge this over here. Okay, and if we look at that, that gives us kind of the color back. So we've gone from there to there. Okay, and then I do another merge, which I just do as a plus, and that's the A side again into the B side here. If you just view that, that gives you this again. And then if we move our light, it does seem to work quite well. So there's our relight taking place. Okay, so I'm not saying this is the official way of doing it. It's just one way that you could do it. It's one way that I quite like to do it sometimes. Okay, so that is your position, points, depending on what you want to call it, normals, and also Z depth. We also obviously had our motion vectors in there that you would use just a vector blur here. Okay, so let's now return back to Maya. Now the reason we've come back to Maya is just to make a quick change in order for our motion vectors to work. For that, we basically need to enable motion vector here. So we need our motion blur on, so we actually get our motion vectors here coming out of Arnold. So with that, we can just go ahead and re-render. And then if we load back into Nuke, once that's done, we can see those now available to us. Okay, so now that's rendered, let's just go back to Nuke, reload that image, jump across to the motion vectors, and there you can see them. So we could very easily now just come across and use that vector blur we talked about. Just apply that here, come into AOV, come into RGB. We want to set the channel that we're going to blur, just the RGBA. The motion vectors are the UV channels. I tend to like it set to forward, and I also like setting the alpha to RGB and alpha. Give it a moment to process. Increase your motion vectors to what you need, and there you can see our motion vectors taking place. Okay, now obviously if we look at the alpha channel, it's solid, and so we don't actually have the alpha for the individual balls, but if we did, we're going to find that this alpha edge is much nicer. Okay, so the fact that it isn't quite blurring across the background is simply because of that alpha issue that we've got. Okay, so back in Maya, let's have a look at how we can build our own custom AOV. So one of the things you'll probably notice from our list here is that we don't have a UV output. So let's go ahead and make a UV output for our scene. Okay, so the first thing we're going to do is we're going to make a new render layer. So I'm just going to come in here and make a new render layer. I've got nothing in it at the moment. I'm just going to call it UVs. And I always do R for render layer. I want to assign all my models here to it. So I select them, right click, add selected objects. I'm then going to come across to my rendering hypershader view here, and we're going to make a couple of shaders, both of them being Arnold. Firstly, we're going to have our AI write color, and we're also going to use a utility here, because this utility, as we saw last week, will let us do a UV output. So I'm going to say that the shading mode, if you remember, is going to be flat, and the color mode is going to be UVs. The AI write here, this is what we're going to use to get our pass out. So if I open this up, the beauty and the input are both going to be this. So I'm going to drag this into both of them, and I'm going to now set a name for this pass. So I'm going to create a new name. I'm going to call it UVs. Okay, so that's what the name's going to be. Create. Now what you'll notice is that in our renderer now, we have a new pass here, new AOV, which is called our UVs here. Okay, so we could define what we want it to be. So I'm going to have it as RGB and alpha, EXR and a Gaussian filter. Now all I need to now do is assign this to this layer. So right click, overrides, and off to the side I'm going to go with assign existing, and then off the bottom, apologies, is the AI utility. That's now applied that. So if I do a quick render, there it is. Okay, there's our utility pass. So go back to my render settings here, jump across to my common tab. I'm going to call this number 5, and before AOVs I want to define what AOV it is. So I'm going to right click and I'm going to say insert the layer name. So it's now going to be called, if I do another underscore, batch render 05 UVs R, which is what I called my layer, and then underscore AOVs. Okay, so I'm happy with all of that. Close that and batch render. And this should go through really quickly. If I didn't add my layer name to the file name, it would actually put it in a UVs directory or folder. But I just want it to be in the root of my images. So we come up to my Finder. Here it appears. There we go. So that's my new custom AOV. Back to Nuke. Let's go ahead and just move over here. Just read in our image. So we're going to start first of all with the image that we're going to apply. So I'm just going to go with Marcy. We're going to read in our render. There it is. We're going to use an ST map to test it. So Marcy, and then the ST map comes here. We're going to say that the channels we want to affect are RGBA, and the UV channels are going to be RGB because they're obviously just red and green here. If we view that, you can see there we have it. We now have Marcy textured on each one of these spheres, which is exactly what we want. We're basically getting the UVs to retexture these spheres. So that's how you can create a custom AOV. Okay, so back in Maya, we're going to have a look at how we can build a couple of custom mats. So I'm going to open up my node graph here, or my node editor, and I'm going to make a AI standard. In fact, I'm going to make 3. AI standard and AI standard. Okay, so we've got these 3 here. Now in the shading group, I'm going to come to Arnold and I'm going to come down to other AOV and I'm going to add another custom one. We've already got our AOVs. I'm going to add another one here that I'm going to call red mat. I'm going to make another one called green mat, and I'm going to make a third called blue mat. Okay, so there are 3 mats that we've got here. Okay, so let's now come across maybe to our hyper shader. I keep finding different things are better for different setups. So from here I'm going to make 3 surface shaders, and I'm going to make the first one red, next one green, and the final one blue. Okay, so we've got red, green and blue shaders here, and then here we've got our AI standard shaders. If we just come back here, we can remember they're called 1, 2 and 3. Okay, so let's move that out the way. I'm going to grab 1, 2 and 3 and these ones, and let's make them all appear together so that we've got them all here. Okay, so we've got our red, green, blue, and we've got our number 2, number 1, and number 3. Okay, so that's kind of neat in a strange way. So this one so we remember what's going on. We're gonna make this one red. This one we're gonna make blue, or green rather, and this one we're gonna make blue. And we're gonna assign the red, green, and blue of the AI standards to this one. So that's the red. Make sure we can see it, and make sure here we're on our right render layer. It looks like we're not, so let's just first of all select these. Should have done this in the first place. Make a new render layer here, and then assign them. So red, green, blue, and I'm going to make one more surface shader, which I'm going to make black and black in the matte, which will work out as a holdout matte. So that's going to be applied to here, 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 and here. Okay, so these will be holdout mattes. These will be our first set of mattes. So the way this works is we come across, and we need to make sure we have the right ones. So I'm just going to select these and just neaten them up a bit. There we go. So we're going to start with the red, go to its shaded group. We want to take the red surface shader and drag it into the red matte. This comes up. This is where you need to keep your wits about you. So the out color, which is the red out color of the surface shader, we attach to the AI custom AOV red channel. Okay, so it should go in to the red channel under inputs. Now we need to make absolutely sure that that's right. So we've got red channel surface shader 1, which is red. First bit's done. Then we go to the green one, which is this one. So that's the green one. We now take our green surface shader, middle drag it across to the green area. Let's make sure that we're still viewing the right one. So it's here. So we now say out color into, and this time we're looking for the green matte. So it should appear in green. So far we've got red in red, surface shader 2, green in green, and then finally this one is the blue. So we take this one, middle drag this into the blue, out color, AOVs, blue matte, blue, here into the custom AOV, And again, we check it because it is difficult to get it right sometimes. Blue into blue. Okay. If we go back to our renderer, I'm going to change this to 6. Our new layer, we're going to give it a sensible name, which we're not going to call layer 1. We'll call it Mat 1, R for render layer. AOVs, you'll see that we've got our UVs, which we don't need anymore. I'll delete that. And we've got our blue, green and red that are going into the EXRs. We're going to check that driver again just to make absolutely sure it's going into a single EXR, which it is. Merge AOVs. So we should be able to close all this down. Save the scene and do a batch render. It should go through really quickly because it's only now doing just very basic colors. Over in one of our Finder windows, you can see here it is. So let's load up Nuke. Drag this over. View it. And we should find we've got red, green, and blue with the appropriate holdouts as well. Red, green, and blue. Perfect. And if we wanted to bring them together, we could obviously do a K for copy. And we could say copy the red mat red into the red channel. So if we look here, we'll see it beginning to appear. There it is. Green dot green into the green channel. There it is. And then blue mat blue into the blue channel. And there that one is. Okay, so if you wanted to bring them together, you could easily do that. So just looking back at what we wanted to look at in this class, we've done the standard render passes, the AOVs, the multi-channel EXR. We've looked at custom AI write color nodes and also custom AOVs for mats. And also we managed to get deep in there reasonably early in the class. So I think that probably brings us to the end of this lesson. Next week we'll be looking at particles and volume fluids. So any questions on this class or anything we've covered, pop them in the forums and look forward to seeing you next week. Until then, this has been Matt Leonard for FX PhD.